End of the whole section on classifying materials. This section is about changing materials. It covers useful products from organic sources, useful products from metal ores and rocks, useful products from the air, and changes to the earth and atmosphere. First, useful products from organic sources. Organic means from living things. Organic chemistry is the study of carbon compounds. This includes everything that is living or was once living. Compounds made from only carbon and hydrogen are called hydrocarbons. In nature, there are millions of organic compounds. That's because carbon atoms can form strong covalent bonds with each other. They can also join together easily to form chains of different lengths to make many different hydrocarbon compounds. The simplest forms of hydrocarbons are called alkanes. They're all inflammable gases and useful fuels, such as methane, ethane, propane, and butane. All alkanes have a central chain of carbon atoms surrounded by hydrogen atoms. This is methane, CH4, ethane, C2H6, propane, C3H8, butane, C4H10, and so on. The burning of alkanes is a most important reaction. During combustion, methane and oxygen give carbon dioxide and water. This reaction is very exothermic. It gives out heat. So many alkanes, like methane, are used as fuel. If there's too little oxygen, then incomplete combustion takes place, giving carbon, soot, and poisonous carbon monoxide, as well as carbon dioxide. All hydrocarbons burn well to produce carbon dioxide and water. Some of the most useful hydrocarbons can be found in fossil fuels, like coal, gas or oil from under the ground. It's a hugely important industrial process to separate crude oil into the many useful different hydrocarbon products it contains. As you watch the next clip, note down some of the different hydrocarbons found in crude oil and the processes used to separate them.
Crude oil is a mixture of liquids and gases. These are mainly hydrocarbons, molecules containing only hydrogen and carbon. Much of the oil extracted from the North Sea is transferred by pipeline to Grangemouth, where it's refined on a massive scale. Fractional distillation separates out the useful components. Hot crude oil is fed in at the base of a tall column, which is kept hotter at the bottom than at the top. Fractions like diesel oils, which contain heavy hydrocarbons, tend to stay near the bottom of the tower. Lighter hydrocarbons have lower boiling points, so they vaporize and rise up the tower, where they cool and eventually recondense. The naphtha fraction, which is used for making plastic, is extracted near the top.
So the first process was fractional distillation, in which crude oil is separated into different substances, or fractions. Different fractions have different numbers of carbon atoms. That means they have different boiling points, so they condense off at different places up the fractionating column. The more carbon molecules, the higher the boiling point. Here's a laboratory demonstration of how fractional distillation works.
Crude oil is a liquid. Many hundreds of solids and gases are dissolved in it. When it's heated, vapours are produced which rise up the glass tube and along the connecting tube to the right. The temperature of this vapour is 68 degrees Celsius and steadies there for a few minutes while it's being produced. As the vapour passes along the connecting tube, it's cooled and condensed into a liquid by a jacket of cold water. This liquid, the first fraction, is collected in a test tube. Then the temperature starts to rise again. The vapour in the tube now looks whiter. The temperature steadies at about 113 degrees Celsius. This condensed vapour collects in a second tube. Soon the temperature rises again. More vapour is given off and the temperature settles down at 165 degrees Celsius to produce a third fraction. Finally, at 212 degrees Celsius, a fourth fraction is produced. Each of these fractions are made up of different chemicals. The first fraction burns very easily and is used to make petrol. The second fraction doesn't burn quite as well. Most of this is converted into petrol by another process. The rest is used to make chemicals for plastics and detergents. The third fraction only burns with a wick. It's used to make paraffin and jet engine fuel. The fourth fraction again burns with a wick, but it makes a very sooty flame. This is used to make diesel engine fuels.
Starting at the bottom, where it's hottest, the heaviest fraction with the most carbon atoms and the highest boiling point condenses first. That's diesel oil, used as fuel in diesel engines and in the manufacture of other chemicals. Next up is kerosene or paraffin, used in jet fuel or for heating, and in the manufacture of detergents. Next, naphtha, used to produce plastics. Then petrol, used in cars. And finally, at the top, where it's coolest, the refinery gases come off, including the alkanes like methane and propane, to be used as fuel. The residue left at the bottom goes to make lubricating oil, grease and bitumen for road surfaces, roofing and waterproofing. Here's a selection of questions you might get about fractional distillation. Why can petrol and diesel be separated by fractional distillation? The answer is that they each have different boiling points. Note that for 1 mark the question only asks why and doesn't want an explanation of how fractional distillation works. Here's a variation. How does the number of carbon atoms in a hydrocarbon affect its boiling point? The more carbon atoms a hydrocarbon has, the higher its boiling point. It would also be correct to say that the fewer carbon atoms it has, the lower its boiling point. And again, for 1 mark, the question does not want a big explanation of how fractional distillation works. Here's a more detailed question on the same subject. Crude oil consists of a large number of different compounds. Explain how fractional distillation is used to produce useful compounds from crude oil. In this question, you're expected to write in sentences about fractional distillation. There are 3 marks on offer here, so you need to make at least 3 different points in your answer. A fairly full answer would go something like this. Crude oil evaporates in a fractionating tower. The different hydrocarbon compounds in the crude oil have different boiling points. That means their vapours condense at different temperatures in the tower and can be collected as purer liquids or gases. Each fraction contains hydrocarbons with different numbers of carbon atoms, and each of these has different uses. Note that there's no need to write lots of detail about the fractionating tower itself and all the different products it produces. There's more about the production of useful organic compounds in the higher tier programme. That's the end.